Hello students, our today's topic is Predictive LL1 Parser, which is from subject compiler design in 6th semester. Myself Mayank Namdev, assistant professor in computer science and engineering department, SIRT Bhopal. So outline of today's lecture is definition of parser, various types of parser, top-down parsing, LL1 parser, uh, various steps to create LL1 parser, and apply these parser for parsing procedure. So firstly we start with the definition of parser. A parser, also known as syntax analyzer, is a compiler or interpreter component that breaks data into smaller elements for easy translation into another language. A parser is a software component that takes input data and build a data structure like parse tree, abstract syntax tree, or other hierarchical structure, giving a structural representation of the input while checking for correctness. As its name implies, it's syntax analyzer. So use of this phase is to check the input sentence which is syntax wise correct or not, which match the grammatical rule or not. If sentence is not follow the grammatical rule, it refer to error handler. A parser may be programmed by hand or may be automatically or semi-automatically generated by a parser generator. So we have lots of options to programmed or implement parser, maybe maybe with the help of hand coding, or maybe with the help of some automatic tools like Yak can use for generate a parser. So in this diagram we have seen that parser takes input from lexical analyzer in the form of tokens, and the output of parser are a parse tree, which is passes to the rest phases of the compiler. Here we also seen that the symbol table is connected by these phases. The role of symbol table is to store the store the database of the compiler in it. Now we come to the next is various types of parser. There are two types of parser, top down and bottom up parser. These two types are based on the derivation technique, which is LMD, leftmost derivation, and rightmost derivation. Top down parser uses leftmost derivation technique, and bottom up parser uses rightmost derivation techniques. In leftmost derivation techniques, for the derivation or generation of any string is based or can be generated by the leftmost values. The leftmost variable can be substituted, but in the rightmost derivation, the rightmost variable can be substituted to generate the required string. Top-down parser again classify into two categories: top-down with full backtracking and top-down without backtracking. Top-down without backtracking can be classified into two types: recursive descent and non-recursive descent, which is known as LL1 or predictive parser. Similar bottom-up parsers can be classified into two categories: operator precedence LR parser. And LR parser is a four type: LR0, SLR1, CLR1, and LLR1. Here LL1 and or all bottom-up parsers are also known as table-driven parser, because the parser can be represented by a parsing table for the check the grammatical rule in it. But recursive descent or backtracking parsers are uses the some predefined procedure to implement it. So now we can come into the what is the meaning of top-down parsing. As its name implies, we start from the top. Top means from root node, and then again and again produce the desired string, desired sentence, or desired terminals with the help of some production rules. Here we use the leftmost derivation techniques to produce the desired sentence. When the parser starts constructing the parse tree from the start symbol and then tries to transform the start symbol to the input, it is called a top-down parsing. To build a parse tree, repeat the following. We have to follow the steps to generate or produce any given input string. First step, at a node labeled A, select a production. A produces small a and construct the appropriate child for each symbol of F. When a terminal is added to the fringe that does not match the input string, backtrack. For parsing, we are always given a targeted string which we have to generate. That we try to generate that string from the given grammar. If that string is not able to generate it from the grammar, that is not a part of that, and there is a condition of error. So with the help of top-down parsing, we try to generate that targeted string. So in the first step, we start with the node A, where we have production. Capital A produces small a and construct the appropriate child for each symbol of him. When a terminal is added to the fringe that does not match the input string, but that is, if we try to generate a child which is not a part of our target string, then we backtrack to the previous variable and try to find some other productions in it. Step third is here, find the next node to be expanded. The key selecting the right productions in step 1. So step 1 is used for produce again and again the various appropriate child from given productions rules. Here we see an example to how we apply top-down parsing. So we have given up production rules where S is a start variable which have two productions, another variable in grammar which have also two productions, and B produces small c, and d. Our targeted string is ACCD. So we want to generate this string by the given production rule. So first we start with the start variable S. We have two options here from S. S produces a small a capital AD or AB. So firstly we try with small a capital AD. So S produces small a capital A and D. Here small a and small d are terminals, but a is variable, so we replace a with their productions. So we have two productions of a small b and small c. Firstly we use a produces b, so a can produce b. Now we read the leaf nodes here. So leaf node are small a, small b and small d, but our targeted string is ACC which do not match with this result. So we again backtrack and and substitute A with their other production, which is C. So A produces C. We again read the leaf node from left to right and find that AC D, which again not match with our desired result. So we apply backtrack here two times. So we reach the start variable and use the other production of start variable, which is small a capital B. So here we see that we have another variable which is small capital B. So substitute the value of B, which is CCD. So after applying CCD, we read from left to right leaf nodes and we get our desired result. So these productions are justified by the resultant string. Now we come at the definition, or what do you mean by predictive or LL1 parser. So firstly we explore the meaning of LL1 parser. So we have find three letters like the first L in LL1 refers to the reading sentences from left to right. As we know, the high-level languages or any programming languages follow the English sentence reading rule, which are from left to right. The second L refers to the with derivation technique we have used here. So in the top-down parser, we are using a left node derivation, and the one in the parenthesis implies that the LL1 parsing uses only one symbol of input to predict the next grammar rule that should be used. The meaning of predictive parser means which has the capability to predict which production is to be used to replace the input string. The predictive parser does not suffer from backtracking. As we told earlier that the LL1 is a table driven parser where the concept of backtracking can be ignored. The data structure which are used in LL1 parser are input buffer, stack, and parsing table. So firstly we start how to create LL1 parser or LL1 parsing table. So there are the following step. First step is in given any given grammar for which we want to generate our LL1 parser. Firstly we remove left recursion if there exist. Then we remove left factoring. After from that removed grammar, we calculate first and follow symbol. Then we construct predictive parsing table, and then with the help of this parsing table, we apply our parsing procedure for the given input string to which is to validate that input string which is valid or not for given grammar. So firstly we apply removal of left recursion. Before that we want to know that what is the meaning of left recursion. As we already know, the meaning of recursion is is the procedure or condition where any variable call itself is the condition of recursion. So in the case of left recursion, if any variable call itself from leftmost side, then it is the condition of recursion, but it may be direct or indirect. So here we seen two example. In example 1 we have seen the condition of direct recursion where the variable a produces itself from leftmost position, and in example 2 we have seen the condition of indirect recursion where A produces B, then B again produces capital A. So if we replace B by their production, we find the condition of direct recursion. So these are the two examples of direct and indirect recursion. Left recursion has to be removed if the parser performs the top. If we apply top-down parsing, or if we want to generate LL1 parser, then we have to remove left recursion. So how to remove left recursion? To eliminate or remove left recursion, we have to see an example. We want to see an example. If we have given production A produces small a capital is capital A small a or B. So here we have seen two productions of A. One production is where a direct recursion is exist, and in another which is independent from recursion. So for removal of eliminate recursion, we use the production which are independent from recursion. So capital A produces independent production is which is capital B followed by a new temporary variable which is a dash. So now if we introduce a dash, to what a dash produce? A dash produces the remaining portion of recursive production. So remaining portion is after A we have seen small a. So small a followed by temporary variable a dash and oblique epsilon, because we do not want to do not change the definition of a given grammar. So we introduce epsilon here. So here we seen how to eliminate left recursion. Our second step is in parsing table generation is removal of left factoring. So left factoring is the condition where some set of or some sequence of terminals and variables are seen are present in any production from leftmost side. When repeatedly same values are called, then it is the condition of left factoring. So here we seen in our example, A produces small q capital B and small q capital. So here is seen small q repeatedly come from leftmost side. This is the condition of left factoring. So for eliminate it, we use following rules. The value which repeatedly come from leftmost side, here in example is q. So A produces small q followed by a new variable or temporary variable a dash. Then a dash produces the remaining values which after the left factor value, which is capital B and capital C. So here we seen how to remove the left factoring. Now we follow the third step. For the third step, which is to calculate the first and follow symbol. So firstly we apply the calculation of first symbol. First, always find out the terminal symbol from the first and follow will always include terminal symbols. When we check out first for any symbol, then if we find any terminal symbol in first place, then we take it, and not to see the next example. We have seen various conditions, and we have seen various examples to calculate the first symbol. So in first condition, if a grammar is capital A produces small a, then first of A is small a, which is a terminal. uh, Now if grammar have production like capital A produces small a capital B, then then we see in the first position in production is terminal, which is small a, so the first of A is small a. uh, in third condition, if capital A produces small a capital B or epsilon, here two productions of capital A. So we apply the rule. So from the previous two rules, we have seen the small a is included in first, and in second we have directly produced epsilon from capital A. So the first of A is small a and epsilon. And the last condition for first is when we see no production, like if capital A produces small capital B, C, capital D, means in the first place we not seen any terminals. There is a variable, there another variable, so we have to use that variable for first symbol. So here B produces small e capital D and opening capital A and closing. So in the case of first of A is the first of B. So to take the first transition of B and the first of A is the first of B. So the first of B is small a and is opening bracket. So small a, first of A is small e and opening bracket, and here we epsilon is also added on the first of A. So here we seen various conditions how to calculate or how to check the first of any variable. Now we calculate now we check how to calculate the follow symbol of any variables. So first rule is first put dollar the end of input marker. So we use dollar as an end marker of any given string in follow up, as where s is the as a start variable. Now we have to check that variable into right hand side of given grammar. So if there is a production capital A produces small a capital B small b, and we want to find the follow of capital B, then here we see in the small b immediately follow capital B. So the first of small b is placed in follow of capital B, and if there is a production where capital A produces small a capital B, and we have find after B there is nothing. So in this condition, follow up capital A is included in follow up capital B. And rule number third is if there is production capital A produces small a capital B small b, and in some situation small b return epsilon, then the rule number 2 is to be applicable, that is the follow up capital A will be included in follow up capital B. So these rules we can apply to calculate the first and follow symbols. Now we take an example to apply all these steps to removal of left recursion, left factoring, calculate first and follow symbol. So if we have given a grammar which have five variables e dash t dash and f, and terminals like plus, star, opening bracket, closing bracket, and id. For creation of parsing table from this grammar, we have seen that in this grammar there are no condition of left recursion and left factoring. So we skip these steps and directly reach to third step, that is to calculate the first and follow symbol from this grammar. So first and follow symbol we calculate here. So the we have seen an example. First symbol is in variable e is e produces te dash. So here we seen that e produces te dash, and t is also a variable. So we find the first of capital T. So we find that capital T again produces capital F. So we use a capital F, and we have seen capital F produces opening bracket and id as a first terminal. So opening and id can be included in the first of capital E. Now for e dash, if you find that in case of e dash, we have find directly in the first place is plus, which is a terminal. So plus and epsilon is included in first of e dash. In case of t, we have included opening bracket and id in the similar manner. In case of t dash, star and epsilon, and in case of f, opening bracket and id can be used as a first symbol of grammar. Now for follow symbol, we have used the rules. So first rule of follow symbol is that include dollar in the first of start variable. So here start variable is e, so include dollar in that as a follow symbol of start variable. Now we find e in the right hand side of productions. So we have seen e in the last production of in the second last production, where f produces opening, e closing, and we have seen the closing bracket immediately follow e. So closing bracket is included in the follow symbol of capital E. Now for second variable e dash, we have find e dash at two place, at first production and second production. So and in both condition we have seen that there is no value after the e dash, means no value followed e dash. In this situation, the follow of capital A will be copied to follow of e dash. So dollar and closing bracket for follow same as e and e dash have same follow. Now for t, we have seen t at first production, e produces t dash and e dash immediately follow t. So first of e dash will be included. So e dash first is plus and epsilon, but we when we substitute epsilon at this place, then we have find that nothing after t we have find nothing. So rule number 2 will be applicable, where follow of e will be copied to follow of t. So in after these all these rules, we have found that follow of t is dollar, closing, and plus. Similar of t dash, same as of t and t dash, and it lasts for follow of f is, we have find f with respect to t and with respect to t dash. In these two situations, we have find the follow of f dash will be dollar, closing, plus, and star. So by using the previous rules, we have calculated the first and follow symbol of each variable of the grammar. Now we use these first and follow symbol for generate the parsing table. We have 5 productions in there, and we also written here first and follow symbol. So before we create final parsing table, we create a blank table. In blank table we have use all the variable as a row, as a form of row, and all the terminals including dollar as a column. So id plus star opening closing and dollars are column, and e dash t dash and f are row. So for entry in this parsing table, we use every productions to enter here in individual cell. So firstly start with the e produces t dash. So where we have to write, we in case of e produces t dash, the row of e, the row of e means which variable which produce here is which is e, and the produced value is t dash. So uh, first of t dash is opening and id. So these whole production is written in two columns, a row of e and column of id and opening bracket. Now for second variable production, there are two productions from second variable, a plus t dash and epsilon. So first, in case of first plus t dash, the row of e dash and column of first of this production which is plus. So in row of e dash and column of plus, we write e dash produces plus t dash. Now e dash produces epsilon. So in this situation, when any variable directly produces epsilon, so in this situation the follow of e dash, which is dollar closum, we use these two columns for entry of this production. So in follow is dollar closing, we write e dash produces epsilon in these two columns. Similar for t produces ft dash. So row of t and column of first of ft dash, row which is opening and id. So in these two columns we write complete production, t produces ft dash. Similar in t dash, we first is star. So row of t dash and column start ft dash, and in case of t dash produces epsilon, we have to write this production in the follow set, which is plus dollar at closing. So t dash produces epsilon, write in these three cell value. So last production is for f variable, which is two production here, opening, e closing, and id. So for id, f produces id, we write row of f and column of id, we write complete production, f produces id. And in case of f produces opening and closing, the first of these is opening bracket. So f versus opening bracket, we write f produces opening and closing. So here we use these rules to fill the parsing table or generate the parsing tables. So this is the complete LL1 parser. This is known as the LL1 parser or LL1 parsing table for the given grammar. So the parse tree can be derived from the stack implementation of giving parcel table. Now we use these parsing table. Now we use this parsing table for applying the rules of parsing procedure. Now we discuss about the LL1 parsing. So LL1 parsing, as we seen previous slide, there is some input, some data structure required, which is input buffer, stack and parsing table. So in previous we just create a parsing table. By the use of this parsing table, we can apply parsing procedure here. Input buffer contain the string which we have given to be passed, followed by dollar. So dollar here is the end marker of that sender, a symbol used to indicate end of input string. The stack indicate a sequence of grammar symbol with dollar on the stack initially contain dollar on the bottom, indicating bottom of the stack. Initially the stack contain the start symbol of the grammar on top of dollar. So after dollar we put start symbol of grammar, The parsing table is a 2D array, M A comma A, where A is a non-terminal, A is a terminal. Means we have check always check row of A and column of small a, or maybe it may be dollar. Now for the parsing procedure, if x is equal to a or dollar, parser halts or halt or string accepted. If x is not x is equal to a not equal dollar, parser pops x and advance the input pointer to point to the next symbol. It means if we found in table that x is equal to any terminals and it is not equal to dollar, then pop x and advance the input pointer to next symbol. If x is a non-terminal, the program consult entry of the parsing table and replace the top of stack with production rules corresponding to entry in the table. If entry d is equal to error, call error recovery routine. So these rules can be applied for parsing procedure. Now we use these rules to check any example of input sentence which is validate for given grammar or not. So the input sentence which is given us to is id plus id star id, which is generated from our given grammar. So we have seen here we used two data structure: input buffer, input tape, and stack. Input tape contain our given sentence or input, which is id plus id star id, followed by our sentence and marker, which is dollar, and stack contain initially dollar, then after that we insert we push start symbol of grammar, which is e. Now these two are connected by predictive parsing program and algorithm, and these programs as a form of database uses using parsing table, which we have created earlier. Now we use this table. Now we create a table in which we have explained our all parsing procedure. So here with three columns in which the value of stack, value of input tape or input buffer, and what action we have to perform at particular position. So initially we have seen that initially the stack contained dollar and start variable, and input string input tape contain id plus id star id, the sentence which we want to validate, and followed by dollar. So dollar e and input buffer contain these. So we use entries in parsing table to validate these values. So stack values refer to the row in parsing table, and input buffer refer to the column in parsing table. So what we have seen in front of stack, which is capital E, and in front of input buffer, which is id. So we have refer our parsing table, and we have seen that e versus id means row of e and column of id, and we have seen e produces t dash in table. So when we find this condition, then the replace e with t dash, so we pop e from stack and push t dash in stack. So we have replaced e with t dash, but in reverse order, because in productions t as a front value, so these also followed in stack. So we place so we push e dash first and then t. So the structure of stack like first dollar, then e dash, then t, and there is no change in input tape. Now we have find that the top of stack is t, and input buffer input pointer is at id. So find t versus id. In table we have find that we will find value that t produces ft dash. So t we pop t from stack and replace t with ft dash, but in reverse order. So in presently stack, and there is no change in input tab. So in stack we have insert dollar e dash t dash and f. Now stack top is f and current input pointer at id. So f versus id. In table we find that f produces id, so replace f with id. So pop app and insert and push id into it, and now we find that stack top is id and input pointer also content. So this is when we have find the same value at stack top and input pointer, then pop the stack top and uh, one position shift right to the right position, and move input pointer to the right position. So now our stack contain dollar e dash t dash and plus an input pointer currently point to plus. So stack top is t dash versus plus. We have found t dash produces epsilon. So in case in this situation t dash replaced by epsilon means we just pop it from stack. Now we find e dash versus plus. So again we find the e dash produces epsilon. So again pop e dash from e dash produces epsilon. E dash produces plus t e dash. So now so e dash replaced by plus t e dash. Now we seen that plus from stack top and plus from plus in input pointer. So pop plus from stack top and point one position right to the input pointer. So what we have seen in stack is dollar e dash and t, and here id star id dollar, and find t versus id is t produces fd dash. So t replaced with ft dash, but in reverse order. Now we have seen f produces id, f versus id, and so what we have seen in table, which we have seen table is f produces id. So similarly we continue apply these rules from the parsing tables, and at last we have seen that when stack contain only dollar and input buffer also contain dollar, when this situation is we have seen, then the condition of grammar string acceptance has been received. So this is the method to how to parse or how to validate any given input string.